Welcome, students. So, today we will be starting a topic from electrostatics, which is divided into many subparts. Today, we are talking about the first part, which is the comparison of electric field between thin sheet and a conducting plate. Okay. However, if you look into the syllabus, right, for competitive exams or for board exams, we only focus on thin sheets, which could be a uniformly charged insulator or a dielectric. Um, and even sometimes it's mentioned that it's actually a conducting thin sheet. Okay, how it is different from a conducting plate and why there is a confusion between a conducting thin sheet. So if you consider a thin sheet that we show it like a straight line, okay, having some charge with a surface charge density, let's say sigma, okay, and we need to determine the electric field in both the sides. So because it's positive charge, the electric field actually is outwards for both left and right side. So we can say the electric field E is equal to sigma by 2 epsilon naught. That is one of the formulas that actually we are asked to remember um, and actually apply it in our exams. However, what if it's actually a thin conducting sheet, not an insulator? When it's a conducting sheet, the charge should be distributed on both sides of the sheet, which is actually not considered as per our syllabus. So if you try to read some of the advanced books like Resnick Halliday or Griffiths, there you will figure out that whenever they mention about conducting sheet, actually they consider something like a sheet which has charges on both sides. And let's say here the surface charge density is, let's say, sigma prime. Okay, how it is different? Because let's say you give a charge here for a thin sheet, insulating sheet Q, then sigma becomes Q by the surface area of one side. However, when you actually give charge Q here and you have two surfaces, so actually sigma prime is Q by 2A. Okay, and then you need to consider the electric field for that. Let's say X and Y. So there, because of this X, there is Ex in this direction, and because of this Y, there is Ey in this direction. Same for Ex because of this charges here and Ey. Okay. Now, if you compute what is Ex, Ex is because one surface sigma prime is, so which is equal to sigma prime by 2 epsilon naught. And same for Ey equal to sigma prime by 2 epsilon naught. So if you again sum it up, these two things, it will come as E, which is equal to Ex plus Ey, and that is equal to sigma prime by epsilon naught. And when you replace this with this, you will see actually in both the cases you will get the same value. The only point is this particular case of a conducting thin sheet behaves exactly like a conducting plate. Now let's take for example conducting plate here. So I will have some kind of thickness, and let's say charges are on both the sides because it's uniformly distributed on the surface. You need to remember that electric field inside will always be zero. So if this positive surface and this positive surface both will actually have the component in opposite direction inside, and it will cancel out. However, here it will be again, if you remember Ex and Y, so this is Ex plus Ey. Again, this side Ex plus Ey. So the outcome is the same, which is actually of the form you can say, you can represent it as, let's say, Q by 2 A epsilon naught. So the same answer will come in both the cases. Okay. Thank you.